For this question, we need to find the cross product first. So as if that this is the plane, we have the point A, B, and the C. Now you need to find the area of the plane. So the area of the plane, the formula is magnitude of AB cross AC. You can also use a CA cross CB or BA cross BC also can. Okay, so as if that this is a 3 point on the plane, we need to find the AB cross AC. Alright, so to get the AB, we need to find the OB minus OA. Okay, after that, alright, after you get the AB and AC, try to get its cross product. Alright, so to find the cross product, we can have this method as if that we are finding the determinant. So determine the sign first with the positive, negative, positive. Take the sign alternately and then put a minor over here. This is a term for the I and term for the J and term for the K. So put the minor over here. For the I terms, we close up the I row and I column. Then we see the negative 5, 3, 2, negative 2. For the J term, close the row J and the column J. We have a 2, 3, 1, negative 2. For K, the same thing. We close the row for the K and the column for the K. We have a 2, negative 5, and 1, 2. After this, trying to simplify this minor, taking the negative 5 multiplied by negative 2 minus 3 multiplied by 2. So we'll get this 10 minus 6. This will be the coefficient for the I. And taking this 2 multiplied by negative 2 minus 1 multiplied by 3, you will have 2, negative 4, 2 multiplied by negative 2, you get negative 4 minus 3. This is the coefficient for the J term. And the last one is 2 multiplied by 2, 4. 4 minus negative 5, you will get 4 plus 5. That will be K. Alright? So after simplify, you will get this. Yeah? This is your AB cross AC. Then to get the area of the triangle ABC, we're using the formula that is finding the magnitude of the AB cross AC and then multiply by 1 over 2. So this will be how to get the magnitude. You're taking the square root of the I component square plus J component square and the K component square. So finally you get this, yeah, 146 over 2 unit square. Then lastly, you need to get the Cartesian equation of the plane. To get the Cartesian equation of the plane, firstly, we need to get the n first, which is a normal vector, which is perpendicular to AB and the AC. So get the cross product. AB cross AC, this n also equivalent to AB cross AC. You already got the n, and you need at least 1 point so that you can substitute into the plane equation. So for the 1 point, I choose to have a point A. So convert that point A into the position vector. That is our OA. OA equals to I plus 4J plus 2K. And the normal vector is equivalent to AB cross AC. That is a 4I plus 7J plus 9K. This is the vector equation of the plane. R dot n equals to A dot n. Substitute the n and the OA as your fixed point A into this equation. So from here, you can see that you need to find the dot product between the A and the n. So the dot product, how do you get the dot product? You're taking the coefficient of the I and multiply by this I, plus with the J multiplied by this coefficient of this J, and taking plus sum with the coefficient of this K multiplied by this coefficient. So you get this and simplified it, you get 50. Finally, the question asking for the Cartesian equation, as if that your your R is xi plus yj plus zk, and then again you find the the dot product. So the equation will become 4x plus 7y plus 9z equals to 50. This is your Cartesian equation.